This is a neat 2016 question from the laws of motion. The problem is like this. A bullet of mass m moving horizontally with a velocity strikes a wooden block of mass 2 kg, which is suspended to a light and extensible string of length 5 meters. It's a long sentence. I'll stop there for a minute and explain what is the meaning of that. There is a small bullet of mass 10 gram. If I have to convert that into kilograms, 10 into 10 power minus 3 kilogram, that is 10 power minus 2 kilogram or 0.01 kilogram. Moving with a velocity of 400 meter per second, strikes a wooden block while it is moving like this. It has striken a wooden block of mass 2 kg, which is suspended by a light-weighted string of length 5 meters. Right? Yeah, that's what he has given for you. Then it is said, as a result, the center of gravity of the block found to rise a vertical distance of 10 centimeters. So what happened is, as there is a height, this has moved up and therefore the block has raised a certain height. This is how the block is. By how much? When compared with the center of the gravity, it has raised a height of 10 centimeters, that is 0.1 meters. This way, it has just moved up this way. Then the speed of the bullet, it emerges horizontally from the block will be. So the bullet will come out. With what velocity the bullet is coming out is the question, right? That's the question that's being asked, right? Speed of the bullet emerging out. So first of all, what we can apply is, there is a collision. Definitely we can apply conservation of momentum according to law of conservation of momentum. P initial equal to P for the entire system. P initial for the system is momentum of the bullet, that is mass of the bullet into initial velocity of the bullet, plus mass of the block into velocity of the block before the collision. Then after the collision, mass of the bullet into velocity of the bullet plus mass of the block into velocity of the block. Velocity of the block initially is 0 because it is in the state of rest. Let us substitute the data. Mass of the block is 0.01 kilogram. Mass of the bullet is, velocity of the bullet is 400 plus mass of the block is 2 kilograms. But initially that is in the state of rest. Here it is just suspended. So that is 0. Again, mass of the bullet is 0.01. Velocity of the bullet that we don't know, we have to find out. Mass of the block is 2. Velocity of the block after the collision we don't know. For that, to find out that, he has given a height to which this has been raised. So what we can say is that block is now getting a velocity u after it strikes the bullet, and then because of that velocity it has raised to a height h. So what we can say for block, applying law conservation of energy, it is moving with a velocity mv. Sorry, it's having some kinetic energy, so I can write half mv square. Yeah, half mv square, velocity of the block square. That is after the bullet has striking the block. Then that has raised to a height h, mg h. Right? So these m's can be cancelled. So velocity of that block after the collision becomes root 2g h. How much is that? Root 2g value is 10, h is 10 centimeter, that is 0.1. That is root 2 meter per second. So here you got velocity of the block as root 2 meter per second, right? Then substitute in this equation. Yeah, that implies 0.01 means 1 by 100, that is 4 itself. This 0.01 and these two zeros will cancel. Plus this term is 0, equal to 0.01 times of velocity of the bullet plus 2 into velocity of the block is root 2. So once if we simplify this, let us see what happens. 4 equal to 0.01 into velocity of the bullet plus 2 root 2. So velocity of the bullet is 4 minus 2 root 2 by 0.01. Get this to the denominator. That is 4 minus 2 root 2 into 100. 4 minus 2 into root 2 is 1.414. Altogether multiplied by 100. You simplify, you'll get an answer of approximately somewhere 117.2, something like that, meter per second approximately. So the closest answer, there is no exact answer, the closest answer is 120 meter per second. That's how we have to solve the problem. And if you notice carefully, we have used a standard thing when there is no external forces acting. Momentum is conserved for the entire system. And again, for the block, we have used conservation of energy, that its potential and kinetic energies are equal, because with the kinetic energy, it has raised to a certain height converted into potential energy. Thus, we got the velocity of the block. By substituting that in the conservation of momentum equation, we got the velocity of the bullet itself. That's how we solve the problem. Thank you for watching.